Good morning, students. Today we are starting the complex analysis analytical function. Okay. So, what is the complex analysis? Like uh, real number, the set of real number. Similarly, we can say the set of the complex number also exists. The complex number is always in the form of x plus iota y. Okay, so there we add imaginary part also in real number, then convert in the complex number. So the complex number is also make a set, a universal set. This is called the complex number set. And study about the complex numbers are called complex analysis. So this is very interesting topic of complex analysis and analytical function. Some function, complex number, how to behave the complex function. So myself, Dr. Govind Sharma, Assistant Professor Mathematics. We will continue with complex number. So the objective of the complex analysis is to know about the analytical function, to know about the complex circle. Complex circle means a complex number is also make a circle, define circle, to understand the properties of analytical function. And after this, we have the five questions, important question for you in a quiz. So continue, start with our lecture. Now come to the lecture. See, student, I told you that let we behave the complex number we show with x plus x plus item. That means what is the mean of this? Here x is real number, y is real number. If you plot a complex number a plus item, we take here a plus, we take here a and item, like a and item. And this y axis we can take imaginary axis, and this is the real axis. We can say a this coordinate is a0 and this coordinate is 0, and this is the imaginary space. This coordinate also we get, so this point we get e. So the modulus of this become x square plus y square. Now it same with the real number, real analysis. We study about the limit, continuity, differentiability. In also the complex analysis, we also read about continuity, limit, differentiability, these things. Okay. So first we come to the point of limit. What is the limit and how it behaves? So what is that? Okay, one more thing. If z is x plus iota y, the conjugate of this will become x minus. Okay. In polar coordinate, x is equal to r cos theta, we put y is equal to r sin. These are some parameter and x and y value we will use in randomly. So if we write z square is equal to x square, if we write z is equal to a, this is the equation of circle. How we can write x plus iota y and modulus will become x square plus y square. So this is a circle. This is a circle where radius is 0 0. Sorry, center is 0 0 and radius is okay. Radius is so. This equation is showing the equation of circle in complex number. So whenever we given in the question z modulus of z is equal to a, so that means we are talking about z is equal to z minus a. If given sometime z minus a is equal to r. So here we can also write x minus delta y minus a equal to r. So x minus a plus iota v r. So here x minus a plus square plus y square is equal to. So this equation can also be written as x minus a square plus y minus 0 square. Center is become a0 and radius is become. So this is the equation of circle. Okay, this is the equation of. So this type of question, this type of important topic, important clues we can say, and these are the important for remind. We can already read in 12th standard. Okay, now now we come with our concept limit. Okay, what is the limit? Limit. Let fz be defined and single value as a value in a related neighborhood point z is equal to. We say that the number L number L any number L is the limit of let fz be defined. Fz is a function which is defined and single value in a related neighborhood. Related neighborhood means if you make a neighborhood of z0, z0 minus delta and z0 plus open interval, z0 minus delta and z0 plus delta, and z0 is not a part of this interval. We remove from this interval. Then we can say this is a related neighborhood. We say that the number L is the limit of z is equal to if for f the positive number positive number upside upside is any positive number exists upside is any positive every positive number means very minor very small positive number such that there exists upside then there exists there exists a positive integer or positive number delta such that estimate such that 0 z minus z0 is less than that implies fz minus l is less. The meaning is that if for z minus z0 is less than delta, we have always find a epsilon. Then fz minus l is less than epsilon. Then this is called the limit. Okay, this is called the limit. Now, now we will show that a function is fz is equal to fz square. Okay, we have to prove that fz if z moves to z0, the fz is also at the limit z0. Prove that theorem if fz is equal to z square, prove that prove that fz is equal to z. Prove that. Let us change meaning first. Now we come to the now how to prove? We will show that z tends to z0, then fz is also equal to z0. So we must show that there exists a epsilon here. Here we must show given any epsilon is greater than 0, we can find a delta. For that case we find a delta such that z square minus z0 का square because fz is here z square. So we take z square minus z square is less than or scalar whenever 0 is less than z minus z0. Okay. If delta is less than 1, then 0 imply z square minus z0 square is equal to z minus z0 z plus z0 delta z. Here we arrange at z0 minus and z0 plus plus z0. Here we add and subtract one z0. We can say that delta, it can be written as z minus z0 plus z0. That means that delta, this will come 1 because it is less than 1. So 1 plus z0. Let delta is equal to minimum 1 epsilon upon 1 plus 2z0, because because 1 to epsilon z0. Epsilon is very small quantity, then delta we take from very small. So z square minus z0 square is less than fz is equal to become. So this is z minus z at 0. Okay. Now we come to the next concept, continuity. What is the meaning of continuity? What is the meaning of continuity? And if function f is said to be continuous at point if for every epsilon greater than 0 there exists a delta s such that fz minus fz0 is equal to fz minus fz0 is less than epsilon whenever we have z minus z0 is less than. A function fz is said to be a continuous function if fz minus fz0 is less than epsilon, where z minus z0 is less than delta. If fz is continuous at z0, then fz is equal to. This is the definition of that means a function fz is said to be continuous if there fz minus fz0 is less than epsilon. Actually, this is the basic concept of right side limit and left hand side limit are equal to the function of uh, function at that point. Okay. Now, in the continuity, we can say uniform continuity, differentiable, difference. Let w is equal to fz be a function of z, then fz is said to be differentiable differentiable at point z is equal to z0 if limit del z is equal to f z0 plus delta z minus f z0 upon z, and z is unique and when z moves to z tends to z and delta z is equal to. So these are some important definitions. As real analysis, we already know about the limit, continuity, differentiability, but here one concept added, which concept is called analytical function. So, so, so we come to the analytical function. What is the mean of analytical function? We can write this f dash z, we can write this as f dash 0 is equal to differentiating z is equal to 0 f z plus z0 plus delta z minus f z 0 upon delta. This is the called differentiability. Now we come to the point. Now we come to the point analytical function. What is the mean of analytical function? Analytical and holomorphic function. Analytical. And it can also call holomorphic. Holomorphic function. A single value function, a single value function, a single value function is said to be analytical at point if it is differentiable. It is differentiable every point, everywhere in same neighborhood of its point. That means I explain you. Let we make a function f(z) is called analytical at z0. If we make a interval z0 minus delta, z0 plus delta, where z0 is part maybe or not. So in this point, if we take an interval z0 minus delta, z0 plus delta, in each point, there are infinite points between the interval. Each point, this function is differentiable. So we can say then each point the function differentiable. So this is also be differentiable on z is equal to z0. This function is called analytic function. Okay. Again, I explain if we make a interval z0 minus delta and z0 plus delta. Okay, open interval. Then z fz is differentiable in this interval. In this interval means in each point of this interval. Each point of this interval. Then we can say this is analytic. This is analytic. Okay, students. So this is very important definition, and now the start the very important concept of analytical function also the necessary. Now we show some necessary condition. Necessary condition is nothing but Cauchy-Riemann equation. If function f(z) is equal to uxy plus iota px is necessary, this function is analytical. If if it satisfies the Cauchy-Riemann equation. Cauchy-Riemann. What is this equation? Now, this is very important equation. That means Cauchy-Riemann equation del u upon del x, del u upon del y, del v upon del x, and del v upon y must be exist, must be, and del u upon del x is equal to del v upon del y. Equation number first, del u upon del y is equal to minus del v upon equation number two. These two equations is called Cauchy-Riemann equation. Okay, student? Again, we say that if the value del u upon del x, the necessary condition is that del u upon del x, del u upon del y, del v upon del x, del v upon del y must be exist, and del u upon del x is equal to del v upon del y, and del u upon del y is equals to the minus del v upon del y. This is the condition is called Cauchy-Riemann equation. Okay, Cauchy-Riemann equation. Now, now first as z is equal to z square minus x plus eta y x plus, so we can say x square minus y square plus 2x. Here u is equal to, in this question u is equal to x square minus y square and b is equal to 2. Now we have to show that this is show that this is analytical or not. We have to check this function is analytical or not. So with z square we can write x plus eta y, x plus eta, because z we know z is equal to, we can take. Now by Cauchy-Riemann theoretically we have to check del u upon del x is equal to del v upon del y, and del u upon del y is equal to minus del v. Here del u upon del x is equal to, we get 2x. Del v upon del y we get 2x. Del u upon del y we get minus 2x. And del v upon del x we get 2x. But we put it minus here, we get del v upon del x, del u upon del x. If this is satisfied, this is also satisfied. So you see, del u upon del x we get 2x, del v upon del x. Del v is equal to this, we get 2x. Okay. Here del u upon del y. Del u upon del y we get minus 2y. Del u upon del y we, and del v upon del x we get 2y. So this is equals to the minus of this. So we can say del u upon del y is equal to minus del v. That means the CR equation are satisfied, are, sorry, if CR equation are satisfied, then we can say that this function is null. So students, today in this lecture we do some important concepts like limit, continuity, differentiability, analytical function. Okay, analytical function. For analytical function, we discuss about the Cauchy-Riemann equation. Cauchy-Riemann equation. What is the Cauchy-Riemann equation? Del u upon del x is equal to del v upon del y, and del u upon del y minus del v upon del x. If any function If any function satisfies the Cauchy-Riemann equation, then it's called the analytical function. But this is not a definition. This is a necessary condition. If a function fulfills this condition, then it will be analytical. But converse is not necessary. The statement converse is not necessary. But definition of an analytical function is that a function fz is said to be analytical. Is said to be analytical at a point z0. So this we make a open interval z0 minus delta and z0 plus delta. In this interval, each point fz is differentiable. Okay, each point of this interval fz is differentiable. Then it is called the analytical function. Students, move to our quiz. We come to the quiz. Which is the analytical function? Which function we can say the analytical function? First, I told you that if function is analytical at that point, each point, it it must be differentiable. But 1 upon z, we discussed about 1 upon z first. At z is equal to 0, the function is not analytical. Okay? If at if we take z is equal to 0, the function is not exist. Then function is not exist, and how it is possible? It is differential. Okay. Function is not exist. So fz is e to the power z. The function value I put z is equal to 0. The function is give us value 1. If then z is equal to other point z, z, uh, 2, 3, all points the function is actual. So which functions are analytical function? Actual is equal to e power z. And thus I suggest you that you keep in your mind a holomorphic function. Sometimes in competitive exam, the language of the is this type. Consider a holomorphic function. Then this is the abstract example of holomorphic or analytical function. So keep in your mind that whenever a examiner asks to consider a function is analytical, then you take fz is equal to e power. Now, second, which is CR equation? CR equation is I told you already that for analytical function it is a necessary condition and mu is equal to be not a CR equation. Du upon dx is equal to du upon dy. This is wrong. Du is equal to du upon dx is equal to and C is dv upon dx. This is the right. dv upon dx is equal to minus du upon. It can also write as du upon dy is equal to minus dv upon. And complex function is analytical if it is bounded, it is not continuous, satisfied CR equation, all of this. If complex function is analytical, when it is analytical, then it is satisfied CR equation. Then a function is called to be analytical function. Okay, complex function is analytical. If in this question we can say that it is continuous. If we give that if this is continuous, this is differentiable, and this is satisfied CR equation, then all three uh, are right. But here he discussed about a bounded function. So we should go with C option, satisfied the CR equation. In polar form, Z can be written on circle with a radius. With radius, then with a radius, Z is equal to e to power iota. I told you that we can write Z is equal to e to power iota a and actually many books are in you see that Z is equal to e to power iota theta. When the radius is unit means 1. Then we write Z modulo medium Z is 1 dot e to power iota theta. But here radius is r. So here is the right option. Okay? Here is the right option. Both with the V. So in polar form, Z can be written on circle with radius a. If it gives to radius 1, then A is also right. So both options are right. Because radius is not include what is the radius. R is the radius or we take A given A considered to the unit. Both is the right. A function is said to be singular. It is analytical of each point. If a point exists, there not be analytical. All the points in the region is curved if satisfied CR equation. And singular, a function not exit that point is called singular point. A function is not exit means not be differentiable that point is called singular point. Not be differential that point that means it is not a analytical at this point. If a function not analytical that point a point exists where the function is not analytical that is called the singular point. Okay student? So this is your phrase and very important from question in statement. There is in the examination you find then the sentence are more complex, more confusing. So read every sentence very carefully. Then you give the you can reach some conclusion. Okay, thank you very much.